In mathematics and computer science, an algorithm is a self-contained step-by-step set of operations to be performed. Algorithms exist that perform calculation, data processing, and automated reasoning. An algorithm is an effective method that can be expressed within a finite amount of space and time and in a well-defined formal language for calculating a function. Starting from an initial state and initial input, perhaps empty, the instructions describe a computation that, when executed, proceeds through a finite number of well-defined successive states, eventually producing output and terminating at a final ending state. The transition from one state to the next is not necessarily deterministic. Some algorithms, known as randomized algorithms, incorporate random input. The concept of algorithm has existed for centuries. However, a partial formalization of what would become the modern algorithm began with attempts to solve the Entscheidungs problem, the decision problem, posed by David Hilbert in 1928. Subsequent formalizations were framed as attempts to define effective calculability, or effective method. Those formalizations included the Gödel-Brand clean recursive functions of 1930, 1934 and 1935, Alonzo Church's lambda calculus of 1936, Emil Post's formulation 1 inches of 1936, and Alan Turing's Turing machines of 1936-7 and 1939, giving a formal definition of algorithms corresponding to the intuitive notion, remains a challenging problem. Algorithm stems from the name of a Latin translation of a book written by Al-Khwarizmi, a Persian mathematician, astronomer and geographer. Al-Khwarizmi wrote a book titled On the Calculation with Hindu Numerals in about 825 AD, and was principally responsible for spreading the Indian system of numeration throughout the Middle East and Europe. It was translated into Latin as Algoritmi de Numero Indorum, in English, Al-Khwarizmi on the Hindu art of reckoning. The term algorithmi in the title of the book led to the term algorithm.